The first speaker today is Matthew Areno. He's the principal engineer at Intel Corporation in the Intel Product Assurance and Security Group. He holds bachelor's and master's degree from Utah State University. Dr. Areno holds several patents and has numerous publications in the area of hardware security, system design, and PUF technologies. I had to check with Dr. Areno. PUF is physically unclonable function technologies. Please go ahead, Matthew. Thank you.
Thank you for having me. It's a pleasure to be here. Great to be here, even in the Zoom format, and have my picture up there, constantly reminding me how much gray hair is in my beard now. Great time. But I'm really grateful to be here to be able to chat today. I'll be talking today about identifying our supply chain threats and making an honest assessment of where we are, of what we're doing, and what we need to be doing as we move forward in the future. Starting off with just a notice and disclaimer about the information. So a quick agenda. Who am I? Why am I here talking to you about this? And what makes me qualified to do so? And then getting into the meat. Where are we with supply chain security? What is the current state of things? What does it really look like? And then how do we make an assessment of the risk that we have as companies inside this industry in terms of supply chain attacks? Where are we? What are the risks? What do we need to do to address them? And then finally, what are the resources that are available to us today to be able to help with this? So, like I said, who am I? This was chatted a little bit about Ivor in his presentation. I started my career out at Sandia National Labs, doing primarily internal red teaming, reverse engineering, vulnerability exploitation work. I finished up a PhD at the University of New Mexico with Jim Plusquellic, where I got introduced to PUF technology, and then eventually transitioned over to Raytheon. With Raytheon, I continued doing the offensive-oriented work. I got a little burned out and eventually moved over to the defensive side of the house. That's where I got involved in some of the U.S. government anti-tamper capabilities and technologies and what we were trying to do there and locking these systems down. So building up the defenses, taking the experience I had from the offensive side of the house and using it to create the defenses necessary to keep these systems secure. In 2019, I made a transition here to Intel and now lead the security assurance and cryptography group. The great part about this, though, is I'm still able to be engaged with efforts like the supply chain security. Those things were of critical importance when you're creating high security solutions, understanding what all the threats and issues and the potential attack points are, and now being able to transition that and bring it into Intel and being able to help work on some of the specifications that we're doing in terms of the industry standard organizations as well as U.S. government. So what does supply chain look like in the news? Well, there's, plenty of articles and plenty of things that have happened that all of us can look at, but here's three pretty critical ones. In 2013, in December, many of you may remember Target got affected. How was this supply chain? Well, attackers figured out that they could attack an HVAC system. They could attack one of the suppliers to Target. That HVAC system just happened to have VPN credentials into the Target network. From that HVAC, they were then able to join the network and attack the point of sale devices. That allowed them the ability to pull out information, transactions, customer information, the whole works. In 2014, ForcePoint discovered malicious modules inside of CAD files. So in this case, small plug-in modules in the form kind of like a zip file, had a file inside of them that executes similar to a script. With that, they were able to get that into AutoCAD, manipulate the tool, create all kinds of issues and problems, which they think were, for the most part, were targeting towards industrial espionage type of activities. And thus far, at least as of 2018, this was the last count I could find, there are over 40 different variants of that particular module that they found out in industry. And then in 2020, I don't think I really need to spend much time on this. I'm sure pretty much everyone here knows about SolarWinds at this point in time. Arguably, this was one of, if not the biggest supply chain threat to date that included numerous pieces of malware and malicious exploits and things like that affected the supply chain at many different points, not just one, but multiple different points. So where does that leave the state of our supply chain? Well, Liz Miller said it pretty well. The harsh reality is that the state of our software supply chain is mediocre at best, partially due to the overwhelming complexity of the software supply chain itself. And this applies, I know she's talking about the software supply chain, this applies to hardware. And if it's hard in software, it's, I promise you, just as hard in hardware. Some might say even harder. The ITRC released a breach report in 2020. Supply chain attacks are increasingly popular with attackers since they can access the information of larger organizations or multiple organizations through a single third-party vendor. The unfortunate truth is that many of these smaller vendors don't have the same capital and resources to be able to implement the security at the same scale as larger manufacturers. Attackers know that. They see it as a weakness. They exploit it whenever they can. If you're an attacker, you're always looking for the weakest link in the chain. So these third-party vendors and other organizations that they can get in and find this weak security, like with an HVAC system, that's where they're going to go. And with that information, once they get in there, they use that to then leapfrog into these other larger organizations and bypass some of their security capabilities. CrowdStrike report, 2/3 of respondents think their organization still has work to do on supply chain. I would argue it should be higher, if not 99%. There's always more things that we can be doing and should be doing as an industry to address supply chain attacks. Interestingly enough, only 1/3 of those see supply chain attacks as concerning for their organization over the next 12 months. Hopefully 100% of those of you on this workshop right now, attending this workshop, see that statement as a significant concern. It just tells us we're not taking things seriously. We're not taking the threat of supply chain attacks as seriously as we need to. In my opinion, things like SolarWinds are just a start. It's only going to get worse. So what do we do about it? Well, let's start off by just level setting a little bit. There's a lot of different phrases and terminologies and things like that used in supply chain. There is really no cohesive structure. Everyone seems to have their own little niche way of describing things. So let me tell you how we do it here at Intel, and this is how we're going to build upon it in this presentation. So we have what's called the Compute Lifecycle Assurance Initiative. In that, we break down the product lifecycle into 4 stages: the build, the transfer, the operate, and the retire. Most of the capabilities, the standards, the solutions, efforts, and things like that that exist today that are under development, they're mostly geared towards the transfer, the operate, and then some into the retire phase. How do we log down that aspect of it? Because for the most part, the build stage is up to the individual manufacturer. That's something that in many cases, is unique to them. It may be, a fairly decent sized template that many of us use, and there's a lot of commonalities, but there's really a lot of specifics that go into the build phase. And as such, that's really what I want to focus on in this. So how do we assess that risk in our own supply chain? If we delve into that build phase, what are we looking for? And my proposed way of doing that is actually a 4-step process. The first one is to define what that life cycle actually looks like. What does the build stage look like for you? There's going to be differences. There's going to be alterations and changes. There's some commonality that we can build on, but you've got to be able to uniquely identify this life cycle for you and not depend on simply someone else to do it. Make that life cycle your own and recognize exactly what it consists of. The second thing, identify the threats. What are all the different points of attack by hackers, by malicious people that can come in and affect your supply chain? And how will they do it? The third step, once you know the threats, now I need my mitigations. What mitigations do I have? How do these mitigations address the threats? And where are my gaps? What are the issues that I'm really still going to be struggling with as I move forward? And then that spurs the 4th step, invest, invest, invest. That is all that's going to fix this. We have got to be able to, as an industry, invest the time, the resources, the financials necessary to make these threats as small, as least impactful, as out of scope as possible in the way that we do things. And the key to all of this is be honest about your assessment. Be honest with yourself where you're weak. Be honest with yourself where are the attacks. There is a reason that several talks yesterday were talking about zero trust supply chain. It's because as an industry, we have not been honest about this. We have not made the hard decisions, face the hard realities of what these attacks really are and which ones are actually possible. The fact is, more are possible than we really want to think, and we've got to be honest about that. So let's start with the first step, establish the life cycle. Our supply chain can be vulnerable across all these different phases of the life cycle, the different ways that we do things, the way we develop our products, whether it's a hardware, a software, whatever it may be. And unfortunately, there is no consistent definition. If you go and look up something like the software development lifecycle, and you Google that, you go to the images, you're going to see about 4 or 5 different variants of that. And there are different ways they do deployment. There's continuous deployment, continuous integration, things like that. There's all these different tools for how to do it. But there's some commonalities that we can build upon. So what it really boils down to is understanding what our life cycle is for our particular product and then delving into each stage. So as I mentioned before, with the CLA, we had the build, the deliver, the operate, and the retire. Now I'm going to delve into the build phase. So I want to know, what does my actual build phase look like? What is that life cycle? And then I need to delve into each one of those. And so it becomes this multi-level structure of threats as we go deeper and deeper and deeper into our life cycle. So then, once we've got that life cycle identified, what are the threats that affect our supply chain? What life cycle do those threats exist in? Do they exist in multiple stages of that life cycle, or only one stage? We've got to be able to identify those threats and know exactly where we need to mitigate them in each process. And as I mentioned before, these threats not only affect us as manufacturers, they affect all of our suppliers. Anything that we're incorporating into our product, these same threats threaten those providers as well as us. And again, those attackers, they're always going to look for the weakest link. That weakest link may be in us. Again, I'm not trying to pick on third-party providers. In many cases, it is us as the larger manufacturers that have those weakest links. So we've got to be able to look at this and understand where those threats are and how we can address them. Unfortunately, it's kind of a manual process right now in a large sense. There is some automation coming. Things are getting better, but we got to keep working on this and accept that is the way it is for now and try and make it better. But like I said, a lot of these threats are fairly standard. They may affect us in different ways. They may affect us in different phases of the life cycle, but they're pretty consistent set of threats. So let's look at some of the ones that we come up with ourselves. So as I mentioned, we had this tier where you're recursing into the different stages. And here we're taking a 10,000 foot view of dropping into that build stage. So what does building look like for an integrated circuit? Well, we broke it up into a concept stage, design, integration, manufacturing, testing, provisioning or configuring, and then deployment. And you can see in each one of those phases, we have a set of attacks that might happen at any point during those phases. And you'll see things like insider threats that can happen at any point in time. That's just the unfortunate side of an insider threat. Other things in here, insertion of Trojan components, design alterations, malicious firmware, unauthorized disclosure of information. All of these things can affect our supply chain at different stages and have to be accounted for. Now we're going to delve in a little bit deeper. So this is going into our test and validation phase. So for us, we're looking at an assembly complete, class testing, fusing, system testing, validation, and then shipping. And as you can see, there's a lot more threats here. So going back to the 10,000 foot view, we're looking now at these three phases over on the right. You know, there's only 11 things listed there. Well, now when I've delved in deeper, there's even more, because the deeper you go, the more you can customize these threats for your specific application and your specific process. but you've got to be able to break that down, identify that life cycle, determine the threats, and then put them into the place. And now let's look at software. Software is the same thing. The phases might be a little bit changed, maybe build and integration get swapped around a little bit and stuff. But again, it's identifying this life cycle, laying out all of these threats. And you're welcome to look at these slides offline. I think you'll probably see when you look through these threats, a lot of the things that we saw in attacks like SolarWind, you're going to see them on here. These are the threats that we know exist. In that first slide, the first one I presented, the 10,000 foot view, I gave you a link. We have a document out on the Intel website on that. We actually give you a table full of links to actual happened events that illustrate each one of these attacks. So you'll be able to go in and see that these aren't just things that we're thinking of. These aren't just things that are found in a research paper. These are actual attacks that have happened. So when I started off with just 3 attacks that were in the news, we know there's a lot more out there. Okay, now we have our attacks. The next step, figure out your mitigations. So in this sense, what we really want to do is take that list of attacks, whether you're doing something like the chart that I just showed on here or some other illustration. The next step is to overlay your mitigations onto those attacks. What mitigations are you actually doing for the individual attacks? Are those attacks completely mitigated? Or are they just partially mitigated? Do I need more work on them? Have I done nothing to mitigate these attacks? And that's where we're identifying our gaps. Where do the gaps exist in my current plan? And how do I go from no mitigation to a partial or even no mitigation to a full complete mitigation? And then what do I need to do to go from a partial to a complete? So those are really the 2 or 3 questions you're asking on there. And a really critical thing to remember when you're looking at these mitigations, again, we have to be honest. Mitigations have negative impact. That's just the way it is. If they didn't have a negative impact, we wouldn't be here today because we'd all be mitigating all of these attacks because there's no negative to them. They cost money. They cost time. They affect production. They do. And so it's critical when we're looking at these mitigations to be working with our employees to help them understand, how is this going to impact your day-to-day life? How is this going to impact your ability to do secure development, to create your products, to get things out on a defined time? We've got to be able to work with them and make sure that they feel included in those decisions. And then finally, invest. Create a strategy for this. As with most things, there is no single formula that just figures all this information out for yourself or for you. There's 4 things that we try to look at, or that I've suggested people look at: the risk to your company and the impact to your customer. And yes, those could be 2 significantly different things. Risk to your company, risk to your customer, that risk is not identical in many cases. If you lose IP, that may impact you and your company significantly, but have little to no impact on your end customer. So separate those 2 and know what the impact is to each one. What's the likelihood that this exploit can happen? Is it low, likely, or, well, again, let's be honest, it's certain in some cases that these type of exploits have happened. And then finally, what's the cost? What does it cost to do a partial? What does it cost to do a full mitigation? And yeah, again, unfortunately, those are often separated by a few orders of magnitude in cost. And one of the key aspects of that is it's often driven by current events. And I'm going to get to that in the next slide and some of the suggestions here. So how do I address this? How do I put together this plan? Well, look for your low-hanging fruit. Learn from your attackers. Attackers look for low-hanging fruit when they're attacking your systems. They're looking for the weakest link. Turn that around and use that to create your mitigation plan. What are the things that I can do today that don't cost much, that don't have a huge impact, that don't have a long timeline to do? What's the best bang for my buck? And get it done. And then look at the other things that are going to require substantial investment over multiple years and create a timeline for those. You can't just leave them there and say they cost too much, or they're too hard, or they take too long. Develop a plan and tackle them bit by bit by bit. And then be transparent with what you're doing. We're seeing that push out there. We're seeing the push for being transparent about the vulnerabilities, the disclosures, the attacks that are happening, those same type of things that are coming in, and people are wanting to see the information about attacks and know when a company is attacked. They're going to want to see this from us on the supply chain side. So tell them what you're doing. Give them some confidence. Yes, there's a big adoption of zero trust out there, but that doesn't mean that we can't try to build up some trust. So be transparent in what you're doing. And potentially, most of all, plan for uncertainty. Be flexible. Create these timelines. Make your plans for what you're going to invest in and how you're going to do it. But understand at any point in time, that can get turned on its head. At any point in time, the next solar wind can hit. The next target can hit. The next big attack can happen at any moment, and we've got to be able to have flexibility in our plan to be able to address that as it comes forward. Fortunately, we're not by ourselves. Oh, that's the wrong direction. Get involved. There's resources out there. These are just a few of them. There are a lot of organizations now that are coming together and addressing some of these supply chain issues out in the industry, in government, within individual companies. This is a list of several of those. Find them, find a resource, get involved, be in there and take advantage of the information that they're providing. They're providing a lot of information on cohesive assessment of what these threats are and what mitigations might be necessary. Utilize them. You don't have to reinvent the wheel every time. Use those, but make sure that you're customizing it for your particular solution. In conclusion, supply chain attacks are not going away. If anything, they're just going to get worse. And we've got to be honest about that. We've got to recognize that there are a lot of things out there that we feared for a long time that are probably coming down the pipe. That was the way we felt about solar wind a year or two ago. If I'd asked if solar wind was going to happen, most people would have said, nah, something like that's not going to happen. And here we are. So what's the next big one? We've got to be prepared for that. And that starts with being honest with ourselves about what our threats are and how good we're doing at mitigating them. And we do that by establishing our life cycle, identifying the threats, determine your mitigations, and invest. And that's it for me. Thank you.
Matthew, thank you very much for a very engaging presentation. We do, as a reminder, have a Q&A button, the Q&A button at the bottom of your screen, if you'd like to pose some questions for Matthew. And we already have a couple of keyed up. So let me go ahead and read these out, Matthew, and sure. Ask for you to take a swipe at them. Firstly, did I understand your chart correctly? You mentioned sole source and single source parts. Is there a percentage of these types of parts that is considered low risk to a component's bill of material?
Well, I think there's always a risk. And that risk goes up the more, unfortunately, it goes up the more sources there are for an individual part. And that's simply due to the fact that there is no, at this point in time, no unified standard of this is what everyone must do to ensure the security of their component before they provide it to somebody else for integration into their part. Even individual companies oftentimes struggle with how to put together that information and enforce that on those suppliers. And we've spoken with suppliers before. Hey, if I did this, I go bankrupt. I can't do this. So how do you work with those suppliers to do that? Yes, there's more risk the more you do. So in some cases, the more you integrate from third party. So yeah, in some cases, depending upon the application, you're looking at sole source. You're looking at single source, and you're the only one that's doing it. You're providing everything in it because you have the standards and it complies with what your customer needs. You really just have to weigh that with the customer and recognize that there are differences there, fortunately or unfortunately, until we get a unified, this is the way security will be done everywhere. That's just going to be the way it is.
Thank you. And that was some themes I think we heard yesterday on trusted supply chain and standards. And you certainly showed some great resources in your slides there. I invite the attendees to reference the slides when they're available with all the great sources you put there. Thank you.
Absolutely.
Second question, thank you for a great presentation. In all of the threat areas, which you had in your 10,000 foot view, you had listed insider threat. What are mitigation ideas on this, given it may be the hardest to identify and control?
Yeah, it's insider threat's a tough one. I mean, let's face it, none of us want to assume that our individual employees are malicious. But at the same time, that's a hard part about being honest. Individual employees, all of us, we're human. We have issues, financial issues. We do stupid things. You could get bribed. You could get extorted. There are a lot of reasons, and not all of them are nefarious or malicious on the side of the person. So the way, again, be honest and accept the fact that that exists. A lot of the ways that people are addressing that is trying to put in multi-factor authentication, multi-party verification, things like that. Auditing. Look at your audits. Look at the logs. Look at when you're submitting source code, when you're submitting design files. Who's doing this? What time are they doing it? How long were they accessing this? It is a gap for us right now. As an industry, we recognize that this is a gap. How do we look at all of these log files and pull out the anomalies, use artificial intelligence, machine learning to pull out the anomalies and tell when there's been an insider threat? Right now, really the best we can do and the best we can say is look at those logs, set up the infrastructure to monitor everything that's happening, and try your best on this. Unfortunately, it's going to take time. As I mentioned, most of the mitigations we're looking at right now, these are multi-year threats. And I don't think you're ever going to be able to get rid of it completely, but at least that multi-party verification, the checking of the auditing your logs and things like that, that's a huge step in the right direction.
Thank you, Matthew. And have one just come in. Any thoughts on quantifying the financial health of suppliers as an early indication of supply chain disruptions and how that may lead to other types of risks?
I don't think I've ever thought of that, to be honest with you. And that's probably a good threat to add in here. I am not a financial analyst, but certainly making those assessments and looking at the companies and making verifying and validating the third-party vendors and providers that we're sourcing information out to or depending upon, being able to monitor that and obligate them to provide that information to you as part of the contract. Yeah, that should become a standard practice on this, because certainly there are things that could potentially pop out. It goes back again to similar to the insider threat. What are the anomalies? What are the things that we're looking for? What really says this is a red flag? And how do you keep that from just popping up and you get a lot of false positives type of thing?
Yeah, it is an interesting question. How vulnerable are your suppliers to being influenced? Yeah.
Yeah.
Have one more question that's popped up. Does Intel have different approaches for commercial versus government business?
To my knowledge, no. We treat everyone identically. Now, I mean, we can have customers come in, and those customers may give a set of requirements and things like that that we agree to adhere to through an established agreement. If that's the case, then obviously those get applied accordingly. But I'm not familiar with different aspects of this. You're welcome to contact me and we could try to look up the information. But yeah, we always try to hold the standard and quality of our products the same, regardless of who we're giving it to, government or a regular commercial.
Very good. Well, thank you, Matthew, and thank you for a very engaging presentation. Ira, did you have some comment?
Yeah, I just had a quick question for Matthew.
Sure.
So, hindsight is 2020, but if people look at the different breaches and exploits that we've heard of, how many are sort of like obvious or the low-hanging fruit versus things that are really esoteric? I mean, is there maybe it's hard to quantify, but sort of like if a lot of the stuff is low-hanging fruit, sort of indicates that organizations aren't doing their job versus, if they're all very niche and very esoteric exploits, then maybe those are more corner cases. Do you have a feel for that, or?
So yeah, when you look at them and determining what's low-hanging fruit, again, there is no standard for it. What's low-hanging fruit is going to be unique for your organization because it is based upon what you're already doing. Even though I mentioned you could have a partial mitigation already in place, and maybe the low-hanging fruit is because it's quick and easy for me to go from a partial to a complete mitigation, or it's easy for me to go from no mitigation to a 50% mitigation type of thing. But going from 50% to 100% is 5 orders of magnitude more cost type of thing. So the fact that it's low-hanging fruit doesn't necessarily indicate that the company isn't doing what they need to do. It may indicate that they simply weren't aware of a particular type of attack. And I think that's true for a lot of the people in the industry. I was fortunate enough to be exposed to some incredible capabilities and things like that over the course of my career. I tend to be a little more pessimistic, as my boss would tell you, on these type of things. And the things that keep me up at night are the things I don't hear about in the news, because as soon as I hear about it in the news, I know that, as an industry, we're going to start addressing it and taking care of it. So then I'm looking at all those things on that chart that I still haven't seen in the news a lot. And those are the things that terrify me. But yeah, I think there's some good value there. I hope companies don't get discouraged when they do this assessment. This is hard. It really is. And it takes a lot of time, a lot of investment. And like I said, there's negative aspects. There's impacts to doing these mitigations. There's reasons that the industry hasn't done them from day one. Give yourself some credit. Cut yourself a little slack, but dedicate yourself to fixing these issues.
Great.
Well, great.
Thank you.
Thank you, Matthew. And it sounds like it's very healthy to be paranoid, and
it can be.
I hope it doesn't keep you up at night.
I just hope you have a comfortable bed. Yeah. Yes. Hope you get to sleep at night.
Thank you for an engaging presentation.
Yeah. Thank all our speakers today for the excellent presentations and tackling all the questions they got. So thank you very, very much. I also like to take a moment to thank our sponsors once again, Amcor Technology and Advantest. Amcor, as a leading OSAT, has multiple differentiators in the area of technology, quality, and service. Technology in the areas of the advanced packaging leadership, engineering services, and their broad portfolio. Quality through a quality first culture, execution and automation, and service through design and test through dropship, manufacturing footprint, and local sales and support. So Amcor, we thank you. And Advantest, we'd also like to thank, who was recently rated by VLSI Research as the best ATE company in 2020. Very high ratings was score 9.5 out of 10 in the various categories: technical leadership, partnership, uptime, commitment, trust and supplier, quality results, product performance, and recommended supplier. So congratulations to Advantest, and thank you again for sponsoring. And lastly, I'd like to thank everybody for attending. We will have the slides and videos up next week. You will receive an email, but I want to thank everybody for joining us today and look forward to seeing you at a future MEPTEC event. Thank you.